Speakers are the last link in the audio recording and playback chain. The sound we eventually hear depends a lot on the speakers. Sound recorded on the most advanced format by the most sophisticated instruments can be totally spoiled by the wrong choice of speakers.
What is your room dimension that you're planning to put up your home theater system?
My room dimension is like 10 by 15.
Is it your living room, or you're planning to put up a dedicated room for the theater?
I'm not sure of it. It's going to be in the living room or fully dedicated home theater. So far, I think I'll get the idea when I, talk to you and move around. Since I'm not that much informed about this speaker in my area of this.
Like you watch more of movies, more of music, or what kind of music do you listen to?
Actually, I listen to, almost all types of music. I usually, when I am a little bit, down, depressed or something like that, I listen to the rock music, which enhance my, stimulate my, hormones to bring back to normal. And sometimes when I'm in a good mood, happy mood, jolly mood, I listen to soft music. And about the film, I watched all the types of, the movies, the action movies, slow, romantic, all types of movies. So I think that's my criteria.
The audio recording and playback chain begins with the microphone. The microphone converts the sound into electrical signals. The amplifier amplifies the signal. The equalizer cleans it up and improves the quality of the signal. The mixer channelizes it. And finally, the signal is made audible by the speakers. The speaker is an electroacoustic transducer that converts electrical signal into sound. In other words, its function is exactly opposite to that of the microphone. Therefore, the parts of a speaker are quite similar to those of a microphone. There is a transducer, there is a diaphragm, and there is the casing or the box. However, it is relatively easy to assemble a speaker. While a microphone is manufactured under strict professional conditions, any music enthusiast can pick up the parts of the speaker from the market and assemble his own speaker. Most loudspeakers have a dynamic transducer. A small, lightweight coil called the voice coil is suspended along the axis of a cylindrical magnetic field. When the signal from the amplifier passes through the voice coil, it becomes an electromagnet. The variable field of this electromagnet interacts with the field of the permanent magnet, and the coil vibrates along the axis of the magnet. The frequency and rhythm of the vibration matches exactly with the changing pattern of the signal. A lightweight conical diaphragm is attached to the coil, and the whole system is fitted to a rigid frame. As the coil vibrates, the diaphragm vibrates too. As the diaphragm vibrates, it pushes the air back and forth, and thus the electrical energy is converted into sound energy. The diaphragms are made conical so that they can push a larger volume of air. They are usually made of stiff paper, plastic, or very thin metal sheets. In addition to having low inertia, a good diaphragm is well damped so that it does not continue vibrating even after the speaker stops receiving the sound.
There are like different form factor of speakers. These we call it as satellite speakers because they are compact and they are portable. So they can be placed on a tabletop, they can be wall mounted, they can be ceiling mounted, and they can also be concealed in the wall, so they are absolutely invisible. And we have speakers which are like, we call them as floor standers, which are full range 3-way and 4-way driver system, where you have woofers, a mid-range for the vocals and a tweeter. So it's they're made up of MDF cabinets, wooden cabinets.
Okay.
So we call them as floor standers. And in between these two categories, there is one more category called bookshelf speakers.
Okay.
I mean, bookshelves are a quarter-sized floor standers. There will be a bisected portion of a floor stander like this. I mean, a lot of times you will not be able to accommodate these kind of big floor standers in a living room conditions because they are space occupying. So there are bookshelf speakers available which will give you a performance of a floor stander at a smaller size. But the reason people choose satellite speakers is aesthetics. They are really good looking, they are compact, they are clean, so they don't occupy too much of space.
The system of the transducer and the diaphragm is called a driver. To adequately represent the frequency spectrum of the audio range, speaker systems employ more than one driver. Individual drivers are used to reproduce different frequency ranges. The drivers for very low frequencies are called subwoofers. Those designed for reproducing low frequencies are called woofers. The mid-range speakers are for middle frequencies. The tweeters for high frequencies. And sometimes there are super tweeters that are optimized for the highest audible frequencies. When multiple drivers are used in a system, a filter network called a crossover separates the incoming signal into different frequency ranges and routes them to the appropriate driver. Crossovers can be passive or active. A passive crossover is an electronic circuit that uses a combination of one or more resistors, inductors and capacitors. These are placed between the power amplifier and the loudspeaker drivers to divide the amplifier's signal into the necessary frequency bands before being delivered to the individual drivers.
These are, we call them as passive speakers. I mean, they're just a box with the drivers inside. There is no electronics inside. So they cannot power themselves. So we need to, process the music and power it through an amplifier to a speaker.
Passive crossover circuits need no external power beyond the audio signal itself, but do cause overall signal loss and a significant reduction in damping factor between the voice coil and the crossover. An active crossover is an electronic filter circuit that divides the signal into individual frequency bands before power amplification. When active filter circuits are used, one power amplifier is required for each band pass. Most loudspeaker systems consist of drivers mounted in an enclosure or cabinet. The role of the enclosure is to provide a place to physically mount the drivers and to prevent sound waves emanating from the back of a driver from interfering destructively with those from the front. These typically cause cancellations, for example, comb filtering, and significantly alter the level and quality of sound at low frequencies. When the diaphragm vibrates, it radiates most of the sound forward, but some sound is also radiated from the back. The rear radiation is in opposite phase to the front radiation. A part of the rear radiation may get diffracted by the speaker and come in front. This will interfere destructively with the forward-moving wave and partially cancel it out. Hence, the need for a sealed enclosure. A sealed enclosure prevents transmission of the sound emanated from the rear of the loudspeaker by confining the sound in a rigid and airtight box. To reduce transmission of sound through the walls of the cabinet walls are made thick and are lined with an absorbing material like fiberglass or wool. The internal shape of the enclosure can also be designed to reflect sounds away from the loudspeaker diaphragm, where they may then be absorbed. Thus we see that any speaker system has a number of drivers, and each driver has a transducer and a diaphragm. There is a crossover system consisting of filters that separate the signal into the required frequency bands, and the individual drivers are fed the frequency bands that they have been designed for. This entire system is put in an enclosure whose primary purpose is to absorb the out-of-phase backward radiations. So, what creates a class difference between speakers? Why is one speaker priced at 2,500 rupees and another at more than 10,000 rupees?
A speaker consists basically of two parts, one the driver and one the enclosure. Now both of them are matched in such a way that the low frequency resonance of the entire system goes down, so that we have a low frequency response which is taken care of, which is flat, and also a very good tweeter which is responsible for producing the mid highs and the high frequency spectrums. Now this tweeter here will be a very precision device made with a very precision type of magnet, a very costly type of magnet, which might also sometimes be very expensive and very powerful. And the coils will be also made with wires which will be very expensive and which will be maybe pure copper wires or maybe a mixture with aluminum and some other alloy, so that the springiness of the coil is perfect, and also the interaction between the magnet, the lines of force of the magnet and the coil will be perfect. And there will be special materials which will be devised for making the diaphragms, so that they perfectly spread the sound at precise frequency, at precise energy levels, so that they give a flat response throughout the frequency spectrum they are assigned for. And look at this woofer here, little woofer and mid-range driver here. It has a special fabric which is woven into it, so that it gives a proper dispersion of the sound, and it has a rubber surround and the cap, and it has also an inbuilt amplifier which you can switch on and off with this switch, and you can increase or decrease the overall response of the speaker using this knob, little knob over here. This is the volume control. So this active speaker here has all the elements which are built into it are quite expensive, because it also house an amplifier inside it, a power amplifier which is precise, or maybe sometimes two power amplifiers, one for feeding the low and mid frequency driver and the other only to feed the high frequency driver. And the crossover network stands just before it, so that it also splits the frequencies before it gets amplified, so that we have more accurate amplifier power which are assigned to both the drivers separately. So it is a very expensive thing, and it is also made with much more care, and so that the drivers are also much more expensive. And they are also much more flatter, because in studio systems or in editing suites we need a frequency response, a speaker which has a very flat frequency response, which does not have any ups and downs in any types which will occur, which will cause a kind of bump, and it will, there will be a misjudgment of the quality of the audio.
Let us examine the specification label of this loudspeaker. It says, the frequency response of this speaker is 45 Hz to 20,000 Hz, so that covers the entire audible frequency range. It also says music power 200 watt and sinus power 100 watt. What does this mean?
This speaker that we made the other day is bigger in size, and also as we can see, the individual elements or the individual drivers, the low frequency and the mid frequency driver is 8" in diameter. So this will obviously, being an 8" output, giving a much more area of air displacement, this will be able to deliver much better air displacement. And in terms of air displacement, we can translate that in terms of energy output and wattage. So this is a 50 watt woofer, and this tweeter here is also a 50 watt tweeter. So this entire system is a 50 watt RMS system, 50 watts. Here in this small setup, don't be disillusioned by external looks. This system is also rated at around 40 watts, Yeah, it should have been written here, but it's not. It should be around 40 watts, which with all the elements which are smaller. So size actually matters in this in the acoustic response, and there are several types of measurements that are done and several types of indications that you can get while purchasing a speaker. And the wattage of the output that you want should also be matched with the wattage of the output of the amplifier that you are using, in case you are using a passive speaker like the one that we made the other day. They has to be perfectly matched, and overall to that we have to keep in mind that the entire size of the room in which we are playing the music or in which we are playing the audio, the entire volume of the room, that mass of the air which is contained in that volume of the room has to be titillated. And in accordance to that, only the wattage has to be calculated, so that this much minimum wattage is required for a room of this size. And there are different mathematical calculations and different theories and different mathematical formulas that can be applied to kind of derive them. But generally speaking, a 40 watt or a 50 watt system is good enough to fill a room of about 15 feet by 10 feet, and by the height might be another 14 feet or 12 feet.
So what could have been the wattage of the sound that threw Marty off his feet and shattered the diaphragm? To create a larger than life sound of this magnitude, one requires larger than life size speakers. But what about one for home use?
The memory of all that. No, they can't take that away from me. The way you smell.
This is the one, no?
Yeah, this is the one which we played.
Yeah,
This is a KEF combination with Denon.
I think I'll go for this one.
Johann Philipp Rees installed an electric loudspeaker in his telephone in 1861. It was capable of reproducing pure tones, but also could reproduce speech. Alexander Graham Bell patented his first electric loudspeaker capable of reproducing intelligible speech as part of his telephone in 1876. A few companies, including the Victor Talking Machine Company and Pathé, produced record players using compressed air loudspeakers. However, these designs were significantly limited by their poor sound quality and their inability to reproduce sound at low volume. The modern design of moving coil or dynamic drivers was established by Oliver Lodge in 1898. What about the humble speakers attached to our PCs? Some of these speakers have electrostatic transducers. These speakers vibrate air with a large, thin, conductive diaphragm panel. This diaphragm panel is suspended between two stationary conductive panels that are charged with electrical current from a wall outlet. These panels create an electrical field with a positive end and a negative end. The audio signal runs a current through the suspended panel, rapidly switching between a positive charge and a negative charge. When the charge is positive, the panel is drawn toward the negative end of the field, and when the charge is negative, it moves towards the positive end in the field. In this way, the diaphragm rapidly vibrates the air in front of it. Because the panel has such a low mass, it responds very quickly and precisely to changes in the audio signal. This makes for clear, extremely accurate sound reproduction. The panel doesn't have the free play to move across a larger distance, so it is not very effective at producing lower frequency sounds. Also, these speakers require a power connection to charge the capacitor. Traditional dynamic drivers are still the most prevalent technology. You'll find them everywhere you go, not only in stereo setups, but in alarm clocks, televisions, computers, headphones, and in public address systems. Public address systems with horn loudspeakers are perhaps the oldest and most ubiquitous of speakers. There is something magical about the horn shape. When you have to address a large crowd and you don't have the backup of a PA system, try speaking through a horn and your audibility will immediately improve. The horn improves the coupling efficiency between the speaker and the air. The horn can be thought of as an acoustic transformer that provides impedance matching between the relatively dense diaphragm material and the air of low density. The result is greater acoustic output from a given speaker. The narrow part of the horn is called the throat, and the large part is called the mouth. The most well-known early horn loudspeakers were those on mechanical phonographs, where the record moved a heavy metal needle that excited vibrations in a small metal diaphragm that acted as the driver for a horn. The horn improves coupling of energy from the diaphragm into the air. This kind of mechanical amplification was absolutely necessary in the days of pre-electrical sound reproduction in order to achieve a usable sound level.
History is going to change.
Modern electrically driven horn loudspeakers work the same way.
These horns are basically some kind of resonating devices, and they are also kind of focusing devices. So basically what happens, there is a driver which is mounted to the horn, which has a certain shape, and this shape determines the cut-off frequency of the horn. And as we will all notice, these horns do not have any low frequency response, they have only mid and high frequency responses. So since in voice we mainly need the mid and high frequency responses, these horns are loaded with these horn drivers and they act as a resonating system, so that the output of these horns become much louder than normal output of the horn driver as such. And there is a beaming of the sound effect which occurs through reflections. They are designed in such a way that the sound is pointed only towards one direction, and so you can kind of focus a certain kind of sound towards an audience of large number of people, you know, standing around in a large place, maybe a field or maybe a stadium or whatsoever, or maybe from one end of the street to the other, the sound can be beamed. So these loudspeakers or these horns are specific devices which are designed in a particular way to give a cutoff frequency and to focus the sound at a certain range towards a certain audience.
The festive mood during the Durga Pujas comes with the cacophony. We have to surrender to it to a greater or lesser extent. However, the listening environment in our homes and working spaces are in our control, and we must now turn our attention to that. The interaction of a loudspeaker system with its environment is complex and is largely out of the loudspeaker designer's control. Most listening rooms present a more or less reflective environment, depending on size, shape, volume, and furnishings. This means the sound reaching a listener's ears consists not only of sound directly from the speaker system, but also the same sound delayed by traveling to and from and being modified by one or more surfaces. These reflected sound waves, when added to the direct sound, cause cancellation and addition at assorted frequencies, thus changing the timbre and character of the sound at the listener's ears. The human brain is very sensitive to small variations, and this is part of the reason why a loudspeaker system sounds different at different listening positions or in different rooms.
Speakers has to be carefully selected considering the volume of the room. So I mean, if you buy a speaker which is like 40 watt and put into a bigger place like 40 feet by 40 feet, like 400 square feet room, then obviously you will hear the music. I'm not saying you will not hear it. You will hear even a a rat screaming, but the thing is, you'll not experience the sound. I mean, ultimately, all we are trying to do here is give you a real experience of a live concert. Like when you play music through this, you should actually feel a live singer or a live performer is standing in front of you and then playing the music for you. To achieve that, we need to give a right powered speakers for a right room dimension. At the same time, depending on the speaker wattage, you should also carefully select amplifier wattage. Right. So these both go hand by hand.
The basic components of a speaker are a series of drivers, a crossover unit for separating the frequencies, and an enclosure. Drivers designed for transmitting the higher frequencies are called tweeters, and those for transmitting low frequencies are called woofers. Most common transducers in a driver are electromagnetic or dynamic transducers. But some speakers can have electrostatic transducers too. The purpose of the casing is to absorb the back radiation from the drivers. Horn loudspeakers are probably the oldest speakers. The horn facilitates the coupling between the driver and the air. For best results, the speakers should be appropriately positioned in the room.
Hello?